So this will be the last part. Again, you don't need to watch every second of every video. I do more in the videos than I think you need, more than I would generally do in class, because if you're trying to learn this from home, I think the more examples you get, the better. To do 56, I need to first make both pieces a fraction. That 9's not a fraction. I'm going to make it into a fraction. And then I'm going to change the division into a times by flipping the 4 over 3. I don't think anything's going to cancel. Between the 1 and the 3, there's nothing that will cancel. And between the 9 and the 4, if I look at the factors of 9, they're 1 and 9 and 3 and 3. If I look at the factors of 4, they're 1 and 4 and 2 and 2. And the only common factor that I see is the 1. Nothing's going to cancel. Clearly, I can't cancel a 1 with a 3 other than dividing by 1, which is kind of pointless. So I'm just going to do the multiplication of 9 times 3 over 1 times 4 and get an answer of 27 over 4 for 56. 58, I need to make both pieces a fraction. This is 2/3 divided by 24 over 1. Now I can do the flip and multiply by the reciprocal. So this is going to be 2/3 times 1 over 24. And now I'm going to work on the 2 and the 24. 2 is just 1 times 2. And instead of writing down all the factors of 24, I'm just going to write the pair that I need. It's 2 and 12. The 3 and 1 won't cancel at all. So I'm going to write the 2 as 1 times 2. I'm going to leave the 3 alone. I'm going to leave the 1 alone. And I'm going to write the 24 as 12 times 2. And I'm going to cancel and cancel. What I'm left with across the numerators are 1 times 1. What I'm left with across the denominators are 3 times 12. The numerator is going to be 1. I can't write a fraction without a numerator. It's completely fine to have a 1 in the numerator of a fraction. If the denominator turns into 1, that's when I can stop writing a fraction. So I'm going to say 1 over 36 for 58. I need to make the mixed fractions into improper fractions. The first fraction, I'm going to go 5 times 3 is 15 plus 3 is 18. So I'm going to go 5 times 3 plus 3. I multiply and add. This first fraction, I'm going to make 18 over 5. The second fraction, I'm going to go 3 times 4 plus 1, which is going to be 13. So times and plus. The second fraction, I'm going to make 13 over 3. Now I'm going to change it to a multiply, and I don't need the parentheses if I make a times sign. So I'm going to say this is 18 over 5 times 3 over 13. If I look at 5 and 3, 5 is 1 times 5, 3 is 1 times 3. Those don't cancel. Similarly, if I look at 18 and 13, because 13 is a prime number, and 13 is not a factor of 18, those won't cancel. So this is no canceling, it's just straight multiplying. Just going to multiply the 18 times the 3, which I think is 54. And I'm going to multiply the 5 times 13, which I think is 65. If I did that right. 15, 18 over 5 divided by 12, 13 over 3. Feels good. I wonder if I could do this on my calculator. This seems maybe more than I can do. 3 and fraction. 3, and I don't know how to do 3 and 3/5, I guess. Fraction, forget it, I can't do it. I could do this though. I can do fraction 18 over 5 divided by parentheses fraction 13 over 3, just to make sure what I'm about to write is the right answer. Oh, if you could actually do it right. Sorry. So I should get 54 over 65 for an answer. And because 18 times 3 is 54, and 5 times 13 is 65. So that feels good for problem 60. Now some word problems, and they're hard to explain. They're not particularly hard. So what I've done for each of the word problems, I created a part A and a part B. The part A, in theory, maybe you can just look at it and know what the answer is, because I made the numbers easy. The part B, I took exactly the same words and I made the numbers not so pleasant. I changed, numbers like 2 into 1/2 to make the problem a little bit harder. So I'm going to do the part A, trying to show some algebra so that when I go to part B, I understand the process that's needed. So if I look at 62A, it says it's estimated that each guest at a party will eat 3 ounces of chocolate. How many guests can be served with 5 ounces? Well, so one guest, I can probably do this, would just eat 3 ounces. If I had 2 guests, each would eat 3 ounces, so that would be 6 ounces. 3 guests, this is getting silly, each would eat 3, so that'd be 9. 4 guests, 3, 6, 9, that would be 12 ounces. And if I had 5 guests, this is a silly way to do this, 5 guests would equal 15 ounces. My answer for this is I can serve 5 guests with 15 ounces. This is not a way that's going to translate to ugly numbers. So let me try to get this 5 guests the way that I think I should get it. What I'm going to do is I'm going to take the number of ounces that I have, divided by the 3 ounces that each guest can eat, kind of the ounces kind of cancel, and 15 divided by 3 is 5. So the answer to problem 62A, it's if I have 15 ounces of chocolate and each guest eats 3 ounces, I can serve 5 guests. The key here is understanding this is a division problem, because now I did exactly the same wording, except instead of each guest eating 3 ounces, each guest is eating 1/5 of a pound, which is a god-awful amount of chocolate. And how many guests can be served with 15 pounds? The algebra is going to be the same. I'm going to say the 15 pounds that I have divided by the amount of chocolate each guest can eat is how many guests I can serve. That's why I do the easy problem and then the hard problem. So really, algebraically, I need to do 15 divided by 1/5. This is a division problem with fractions, and it's a special one because anytime I have a division problem with fractions, I can invert and make it a multiplication. So 15 divided by 1/5, which is the algebra that I need to do, is the same as 15 times 5 over 1. And that's just 15 times 5, because 5 over 1 is 5, and that's going to be 75. And maybe I'll write something nice, like 75 guests can be served, rather than just writing something that's not so grammatically nice. It'd be nicer if I said 75 guests can be served with 15 pounds of chocolate, but I don't have the room to write that. And it probably would be better for this last one. I think your 61A and B is similar. You might want to peek at my solutions manual. I just wrote up the solution for this if you're not sure how to get started on it. All right. Well, let's do 63 together, just so I've done one with you here and not leaving you hanging. So for 63, you might want to pause the video and try to do part A and part B. If you can get it, don't even watch me do it at all. But if you can't get it, then we can do it together. So for part A, Rick purchased a bulk package of candy that weighs 6 pounds. He wants to sell candy in little bags. These aren't so little. That weigh 2 pounds. A 2-pound bag of candy, I guess, is not particularly little. But how many little bags of candy can he get? He bought 6 pounds of candy. He wants to divvy it up into 2-pound bags. How many bags can he get? That's super easy, hopefully. If I take the 6 pounds of candy that he has and the 2 pounds per bag, that's going to give me 3 bags, because each bag would have 2 pounds, so I'd have 3 2-pound bags. So there'd be, 1 bag. These aren't really bags, but the idea behind this is Rick could make 3 2-pound bags with his 6 pounds of chocolate, 6 pounds of candy. So Rick can fill 3 bags maybe with his 6 pounds. That, hopefully, if you could read through the problem and understand the problem, that you could do that without any sort of algebra. It's not particularly hard to know that if I have 6 total pounds and I want to break it up into 2-pound chunks, that I get 3 of the chunks. Part B, exactly. If I put 63A and 63B on top of each other, they say exactly the same, other than I changed. Instead of making little bags of 2 pounds, I'm making little bags that make a 1/4 pound. And that makes it all of a sudden, the way I did this, not so desirable. I should have done this. I should have done 6 divided by 2 as opposed to the fraction to get the 3 bags. Because when I come down to part B, this way is too complicated for right now. So same question. Rick purchased a bulk package of candy that weighs 6 pounds. He wants to divvy it up into little bags that weigh 1/4 pounds. How many can he make? It's just the 6 total pounds divided by the size that I want to divvy them up into. And I'm going to invert and multiply. This is going to be 6 times 4/1, which is going to be 6 times 4, and that's going to be 24 bags. So I maybe can say Rick can fill 24 bags with the 6 pounds. But if I just wrote like 24 with a word bags next to it, or little bags of candy, would be fine. So just a few more. It's a long section. I think we've got 3 problems each to do, but a part A and a part B, an easy part and a bad part. Our parts 66, they're so similar that I'll do my 66 as opposed to your 65. 66, half of, which is a key word, the 120,000 registered voters plan to vote in the upcoming election. How many voters plan to vote in the upcoming election? So half of 120,000, well, not everybody that's registered votes. And in a presidential election, maybe 80% of the people that are registered vote. In non-presidential elections, maybe kind of off-year or mayor elections, you might only get 30% of people voting. So this is realistic. So if half of the 120,000 people registered plan to vote, how many people plan to vote? Well, half of 120,000 is 60,000. To get this answer, I'm just going to find half of, and of, I'm going to make a multiply. That's the way I'm going to get the 60,000 people that are going to vote of the registered voters. Let me do this multiplication by making it 1/2 times 120,000 over 1. I don't have a factor sheet for 120,000. And I know the 120,000 will cancel with the 2. Let me just do 120,000 divided by 2. And I'll show you the canceling. I'm going to make the 2 into 1 times 2. And I'm going to make the 120,000 into 60,000. That's an extra 0 there, times 2. And now I'm going to cancel out a 2. And I'm going to be left with 1 times 60,000 over 1 times 1. That's going to be 60,000 over 1. And any fraction that has a 1 in the denominator can be just written as the numerator of in this case 60,000. So I'll just say maybe 60,000 people 60,000 voters plan to vote. 60,000, I'll just say people plan to vote. So the giveaway word here is of. Of usually means multiply. And in your problem, 65, half of the 10,000 voters plan, half of the 10,000 students are taking math, so it's going to be half times 10,000. Your part B is going to work like my part B. Same exact wording, other than I changed some numbers. And the number that I changed in 66B is 3/4 of the 120,000 registered voters plan to vote. How many plan to vote? It's the fraction of the voters times the total registered voters. That's going to give me the number that are planning to vote. Let me write this. So I've got double fraction. I'm a little shy in room here. And for the 120,000, I'm going to divide it by 4 and get 30,000 times 4. So I'm going to make this 3 over 1 times 4 times 30,000 times 4 over 1. I'm going to cancel the 4's. This is going to give me in the numerator 3 times 30,000. And in the denominator, 1 times 1. That's going to give me 90,000 over 1. And that's just 90,000. That's more like a presidential election. You get, 3/4 of the registered voters voting. So let me just try to do something like this. About like 90,000 people plan to vote. I like boxing my answers. I don't know why I didn't box this answer. So your 65 should work exactly the same. They're structurally the same kinds of problems, even though the words are a little bit different. Maybe let's do 67 together, just so I don't leave you hanging in case you need to push. So for 67A, a certain recipe calls for 4 cups of sugar. How much is needed to make half of the recipe? Hopefully you know if you're making half a recipe, half of 4 is 2. Algebraically, if the recipe requires 4 cups and I'm making half a recipe, I would just do half times 4, half of the 4 cups. And that's 1/2 times 4 over 1. And let me do some nice simplifying. Let me just not do the simplifying that I've been doing the whole video, because a lot of you will just do this. You'll go 2 goes into 2 divided by 2 is 1, 4 divided by 2 is 2, rather than taking the time to write out the factors. This is the way that most students will reduce, but it's a harder way to teach. It's not as clear to follow. So the algebra gives me 2 over 1, which is just 2. So a half recipe will need 2 cups. I'll just say 2 cups of sugar is needed. And my sentences aren't really sentences, but something like that would be fine. So for part B, a certain recipe calls for 3/4 a cup of sugar, which is more realistic than 4 cups. How much is needed for a half portion? Well, I need half of the required amount, half of the 3/4. That's going to be the amount that's needed. Exactly the same. I'm doing a half of the total amount. And this fraction's not reducible. I'm just going to multiply across the numerator and across the denominator and get 3/8. And maybe just say 3/8 cups of sugar is needed for a half. Oh, last problem, finally. A monster section. I didn't feel like it was going to be that long. So I think our problems are similar enough that I'm going to do 70 and leave you 69. So 70, a car's traveling at 50 miles per hour. How far can it go in 3 hours? Well, that should be easy. In 1 hour, it's 50 miles. In 2 hours, 50 plus 50 is 100. In 3 hours, that's 150 miles. So if I just take the 50 miles per hour that you're traveling times the number of hours that you travel, you'll get the 150. So it's going to be the car can travel 150 miles in 3 hours. Your 69A is real similar. It's a multiplying problem. 70B is ugly. Car is traveling at 48 miles per hour. How far will it travel in 4¼ hours? The algebra is going to be the same though. I'm going to take my speed times the time. That's kind of a distance equals rate times time snuck in here. This is a formula that says rate, which is my speed, times my time, which is the time, equals the distance. This is kind of a sneaky way to get that formula in. This is ugly. This is going to be 48 over 1 times 4 times 4 is 16 plus 1 is 17 over 4. And now I'm going to lazy cancel. I'm going to go 48 divided by 4 is 12. 4 divided by 4 is 1, rather than writing out the whole factor sheet. But I could have reduced it the same way. I'm just progressively going to get lazy as I think you're getting more comfortable with this. This is going to give me 204 over 1, which is 204. I can say the car will travel 204 miles. Alrighty, so that was way more than I bargained for. I'll pause this and hopefully you can just knock this section out. Next section is adding and subtracting, which I think is a little bit harder.